Hi, my name is Rebecca Parks, and we're going to be going over our content lesson plan about how to use graphs and plots in geometry. Now, the first problem that we're going to be doing is Mr. Smith's class is being tested on their physical education. Part of the test includes weighing each of his 17 students. Their weights are 204, 101, 205, 122, 191, 134, 135, 184, 183, 141, 142, 171, 165, 164, 155, 156, and 163. And we're going to be using all of these numbers to demonstrate several plots and graphs. Now, these numbers look a little bit jumbled and messed up, and you can't really organize them in your head. So what we're going to do is we're going to organize them by place value, and they're going to be organized by the hundreds and the tens place value. And we're going to go up to the ones place value with our stem and leaf plot, but let's just put them in order first. So we've got 204, then we've got 101, 205, and we put 204 and 205 together because it's 2020, 10. We got 122 next. So because there's a 2 in the tens value, we're going to separate that. 191 is separate because it's in the nines place value. 134 is separate. But 135, we're going to put it next to each other because we've got 1, 3, 1, 3. Then 184, 141. We'll put 142 next to it. 171, 165. We're going to put 164 next to 165 because of the 1616. And then we've got 155. We don't have a place value for that one yet. We're going to start another one. 156 next to 155. And then we have 163. Let's separate. And then the last number is 183. And we're going to put that right next to 184 because of the 1818. So we separated all these numbers by the hundreds place value and the tens place value. Now we have them in order from our place value. Now we can move on to our stem and leaf plot. Now we're going to go in order from the least to greatest. Now our lowest number is 101. So this is our key, how we're going to do it. We got our ones and our tens, our hundreds and our tens, and then this is our ones. So that's exactly how we're going to set it up right here. If we had 103, we would put 3 right there, so it would be 103. And that's just how we're going to set up our whole plot. The next thing is the 120s. We have 122. Now 130s, we have 134, 135, 34, and we're just going to put a comma in between it so that we know it's separate. Next thing is 140s, and we have 141 and 142. And then we have our 150s, 155 and 156. And then we have our 160s, 163, 64, and 65. Now our 170s, and we just have one of those on there, 171. Now our 180s, we have 183, 184. Remember we're putting a comma. Do we have any 190s? 191. Let's extend our T a little bit. And then we have our 200s, so that's when this is going to change. We're just going to put 2, 0. We've got our hundreds and our tens, and we've got 4 and 5, so 4, comma 5. So that's the original start of our stem and leaf plot, but now we're going to do the frequency of the plot itself. So for our hundreds place value, you see we've only got one number. And we're just going to put a 1 there. Our 120 place value, we've only got one number there, the 122. 130s, we've got 2 numbers. We're going to put 2. 140s, we've got 2. 50s is 2. And 60s is 1, 2, 3. 70s is 1. 80s is 2. The 90s we have 1. And then for our 200s we have 2 numbers. So that is how you set up your stem and leaf plot. Now you have your numbers completely organized from lowest to highest, and the frequency of how often those numbers and those place values occur. Another way to display geometrical numbers is in a histogram. In a histogram, you don't set up a T, but you set up more of a graph-like, and you're going to put your frequency on the left side and the weight on the bottom. The weight has more distribution, and the frequency, our highest number was 3. So we're going to put that on the left side. So just like last time, we've got 100 and 101. And that only happened one time. So for our hundreds, we're going to make a bar and just color it in. But with the histogram, the difference between a histogram and a bar graph, and we'll go over the bar graph next, the histogram has no spaces in between it. So we have to actually complete the whole bar up until our next number, which is 122, which happens one time. So we're going to keep going till we get to the 122. And then our next frequency, 130, has 2. So we're actually going to go up to the second mark for our 130. Now for our 140s, we have 2. One 150s, we have 2. And that's just right here in the middle of 140 and 160. Our 160s, we have 3 frequency. So we're going to go all the way up. Make sure we hit that 3 mark. And for our 170s, we go back down to 1. So for this one section of 70, go to 1. 180, we have 2. $190, we go back down to 1. And then for our last one, 200, we have 2. And that would be one way that we could display our frequency in our geometrical problem, is using a histogram. As I mentioned earlier, another way that you could do it is a bar graph. However, with a problem like these that have 17 different numbers, displaying them right here on the range from 100 to 200, there's way too many little numbers and we'd have way too many tic-tac marks and displaying each student's weight when the problem is focusing on the weights itself, not each problem. A bar graph would display things like which student likes dogs more, and you would put the amount of students right here and the dogs right here. Just histograms would be more appropriate for this type of problem. Our next one we're going to go over is pie graphs. Now, pie graphs, we would have to also shift our problem a little bit. With the weights, we could spend our time and display, okay, so how many students are in the hundreds range? We had 1, display that, and then 200s is 1, and go back and forth and back and forth. And overall, we wouldn't really have a clear picture. And a pie graph would display if Mr. Smith asks his students which sports they like more. So 7 students like tennis, and 4 students like football. And then let's say the other 7 like soccer. That would be more of an appropriate problem. And the last one that we're going to go over is a line graph. Now we're actually going to introduce some more information. That way we can properly demonstrate what type of problem is best used for a line graph demonstration. So line graphs are mainly used to kind of compare the differences in weights between two classes. That would be, so we're going to introduce the second class of weights for 200, 125, 135, 160, 150, 177, 170, 180, 178, 179, 184, 181, 190, 201, 198, and 197. So we're also, just like last time, we're going to write out our problem. So this is our Mr. Smith class, and now we're going to write out the second class in comparisons numbers. So we've got 202, 125, 135. Remember, we're going to separate it by the hundreds and the tens value. 160, 150, 177, 170, 180, 178, 179, 184, 181, 190, 201, 198, and 197. But even though this one has a 0 in the ones value, and these are 8 and a 7, we're still going to put them together because we're only grouping them for the hundreds and the tens value. So instead of, we already know the frequencies of Mr. Smith's class, so we're going to go ahead and name the frequencies of the second class. For the hundreds value, we only have 1, 2 for the 200s, 3 for the 130s, I'm sorry, 1, 160, 150, 1, 2, 3, 4 for the 170s, 3 for the 180s, 3 for the 190s, and then 1 for the 200s. So, for Mr. Smith's class, on the x-axis, we started out at 100 because we have no properties that are under 100. They all start at 100. So for the first one, frequency is 100 is 100. So we're just going to put one dot right there. Our frequency for 120 is also 1, so we're going to put one dot right there. 130 is 2, so we're going to put one dot right there. 140 is 2, put one dot right there. 150 is 2. 160 is 3, so we're going to go up to the 3 mark. 170 is 1. 180 is 2. 190 is 1, and 200 is 2. Now we're just going to connect our lines. And that is our first line for Mr. Smith's class. Now we're going to demonstrate our second class weights. So our frequency, we don't have any 100s, so nothing there. No 110s. Our first one is actually 120, so we're going to start our line right there at 1. And then 130. And no 140s. We have 150, 160, and then our 170s jumps up to 4. I'm going to go ahead and start making the line. 180 goes back down to 3, so we're going to take our 3. And then 190 is still 3. And then 200 jumps all the way back down to 1. Now for these types of problems, they would ask for which class had the highest drop in weight, 160s, 180s, and we would answer class B, because as you can tell, there's a huge skyrocket here and then a huge drop from the 160s to the 170s. Line graph would be the perfect one to demonstrate the differences in the two weights of the classes. And that is all the graphs that we would use in geometry.